Firstly, we're going to draw a circle, and we're going to make it relatively big. The radius of this circle, we're just going to call it r for now. Then we're going to cut this circle into 4 pieces. Once we've got this, we're going to cut this into 4 more pieces. 4 more, 4 more, and so on, you get the point. The goal we're trying to achieve is to divide these pieces so many times that the divisions become hardly visible, and part of the reason why Archimedes chose the method of exhaustion as their name. As you'll see later, the more divisions we make, the easier this problem will become to solve. Thirdly, we're then going to take these pieces and line them up next to each other until they appear like tiny triangles. This is where the fun part comes. We're going to cut this halfway, take the division, flip it vertically, and wedge it between the other pieces, until we've got something a bit like this. Now, the vital discovery that Archimedes made was, as you can see, this shape slowly starts to resemble a rectangle as n, the number of divisions, increases. Initially, we begin with something like this, but when the divisions increase, so does the similarity the shape has with a rectangle. From here, it's apparent that the area of a rectangle is just base times height. We know the height, it's just one of the divisions, also known as the radius. So we can replace that with r. And the base, although a bit more complicated, actually makes perfect sense. If we were to stick with our initial layout of the shape, not having halved the shape, we would have had one long base. Also, the circumference, 2πr. But considering we split it, we can divide this by 2. Thankfully, the 2's perfectly cancel out, and we are left with πr. From here, it's quite simple to see where we go. We do r multiplied by πr, the r's multiply together, and we are left with πr². Once you decompose a problem like this, it actually becomes quite simple to understand. And you think to yourself, maybe I could have discovered this on my own.